Hello, good morning, student. I hope you all are happy, healthy, and very fine at home. So, what did we discuss yesterday? Yesterday, we discussed about some of the application of the strength of bases. There are three kinds of bases. We know that one is aliphatic basis, second one is a aromatic basis, and third one is a heterocyclic basis. I think we have covered all the application of the aliphatic basis. Today we are going to start the second part, that is a aromatic basis. Aromatic, everybody knows that the aromatic means the compound which fulfill the following criteria, like it should be planar, it should be fully conjugated, and then cyclic. So these are the three criteria, and that obeys the Huckel's rule, 4n plus 2 pi electron. That type of the compound is called as aromatic, and the rest of the compound are the aliphatic. Remember here, aromatic basis, first application we are going to learn here. What is that? First application, for example, aniline. Aniline is a weaker base than cyclohexylamine explained, right? Such type of the question may appear, or you consider here this is one of the major and the important application of aromatic compound. Let us see here, while solving such type of the problem, or what we can call it as answering it in the organic chemistry, you must know the structure of the organic compound, aniline and the cyclohexylamine, right? And most of you, means maybe as a 90 or 95% student knows the structure of aniline. And in aromatic compound, one of the hydrogen atom get replaced by amine group, that is called as aniline. So this is the structure of aniline, right? Aniline, and which is a aromatic in nature. And just now I told you the criteria for the aromatic compound, and they are the very, very stable compound. Now its analog means cyclohexylamine, it is an analog of this aniline. And what is that? Here let us see the structure of cyclohexylamine is this one, NH2, nitrogen containing. And as we know that in general organic, those are the organic compound containing nitrogen atom are basic in nature. Why they are basic in nature? Because nitrogen atom containing as a lone pair, which is non-bonding electron pair, and according to as a Levy's basis, it is readily available for the donation, and therefore they act as a Levy's basis. That is it. This is the structure of cyclohexylamine. This is the structure of cyclohexylamine. If you observe this structure carefully, what do you see here? In the first, there is a alternative carbon-carbon double bond, but this compound there is no double bond. That's why it is saturated. First point to remember here, why aniline is a weaker base. Look at here, and as we know that the factor affecting the strength of basicity, by considering all those factors, there are 5 factors I already mentioned at the while we have started the strength of organic bases. That time I already told you. Let me repeat it again. First one, what is the factor? First one, the availability of the lone pair. Second one, that is what we can call it as the electronegativity of B. third one, the structural effect of B, fourth one, the stability of conjugate acid, and fifth one is the nature of the solvent. These are the factor. By keeping this factor in mind, we are considering we are determining or we are explaining why one organic basis is stronger while another one is weaker on the basis of that factor only. Now remember here, as well as we know that some of the inductive factor, or what we can call it resonance factor, there are the steric effect also. They greatly influence the strength of basicity as well as acidity. Minus I inductive effect, minus R inductive effect, they are decreasing the basicity, whereas on the other hand, plus I effect and the plus R effect both are greatly increasing the strength of basicity. Now look at NH2 group attached to carbon atom that shows the sp2 hybridization, right? This carbon atom is a sp2 hybridization, and as we know that if sp2 hybridization is there, it shows or it exerts minus I inductive effect. There is a minus I inductive effect. Similarly, this NH2 group attached to carbon atom that exhibit the sp3 hybridization. Here sp3 hybridization shows what kind of the effect? It shows plus I inductive effect, and in general we know that plus I inductive effect increases the basicity, whereas minus I inductive effect decreases the basicity. If you see the pK value of this aniline having, I think pKb value I think 9.4 something is there, and this having as a pKb value may be as a 5.8 something, roughly you remember. And again remember, if pK value decreases, basicity goes on increasing. pKb value decreases, basicity goes on increasing. That is one of the general rule you should remember. But here minus I inductive effect, and here is a plus I inductive effect. This is the first point. Now second point, if you look at here, in this case, this lone pair which is present on the nitrogen atom, they are involved in the delocalization. As we know that this lone forming double bond here, and this carbon-carbon double bond concentrate the electron density at this corner point, and we are going to get negative charge here, NH there. Now look at on nitrogen atom, I am putting as a positive charge on nitrogen atom. Why I am putting that positive charge on the nitrogen atom? Because that nitrogen atom is exceed the bond, 2 with double bond and 2 with hydrogen bond, and normal bond of that nitrogen atom is a 3, but here 4, and that's why I am putting the positive charge on it. Remember, this double bond and this double bond, they remains as it is, right? Now this is the electron donating group over here. Now what is happening here? This negative charge forming as a double bond here, and this double bond concentrate the electron density. Observe carefully how I am showing as an arrow. This arrow exactly resting in the middle of these two carbon atom, and this double bond concentrate the electron density at this corner point or at this king, and we are going to get the product here. Another one, negative charge here, double bond forming here, this double bond here, and here is a NH2 positive charge as it is. Another structure you can draw here, this negative charge. Now I am following the clockwise delocalization of this lone pair. This negative charge forming double bond over there, this double bond concentrate the electron density at this corner point, and we are going to get the another. Look at here, this NH2 positive charge remains as it is, this double bond as it is. What are the changes I made in this structure? Double bond here and negative charge here. Now another structure, this negative charge forming as a double bond here, and this double bond neutralizing this positive charge, and you are going to get the final product, double bond here, then NH2. After the delocalization, that lone pair coming on its original position, and this double bond and this double bond, they are as it is. Now you can give the number. This is a structure number first, this structure number second, structure number 3, structure number 4, structure number 5. If you observe the structure number, first and the last are identical, only if you look at here on the right hand side, here is a carbon-carbon double bond. If you look at here, there is a carbon-carbon single bond. They are the identical one. Only shifting of electron is a different one. Now look at this structure, second, third and fourth one. At ortho and para position there will be a negative charge, and while like as a most characteristic chemical reaction when you are going to study at the end of at the last chapter, that is why aromatic compound undergoes as electrophilic substitution reaction. If electron donating groups are there, why they gives ortho and para product? Those are knowing the resonating structure, they can able to predict the product. If resonating structure are something is confusing, then you cannot predict the product. So for predicting the product for aromatic compound, you must know the resonating structure, how to draw. From T.Y.B.Sc, I think maybe from 12th standard you are learning that how to draw the resonating structure of this compound. Only two kind of the let us see here lone pair, and this lone pair when traveling they are operating. Resonance structure means what? The redistribution of electron operating in an unsaturated system via pi bond is known as a resonance effect. So this delocalization, they starts traveling, and so take us a longer time to there, and but in this case these lone pair are readily available for donation. It will pick up the proton immediately and form the product like this. Not this one, there is no double bond, so here just you are going to get this NH3 positive charge over there that get protonated, and that's why this act as a Levy's basis, or this is a stronger as compared to as aniline. So this is the first application as far as a aromatic compound is concerned. Now moving toward the next application, second application. Let us see here second application of this aromatic. We are learning or we are discussing about the aromatic bases. First one important one we have learned. So another one for to sake of understanding that we are going to learn as a second application now here. Second application, suppose as we know that the aniline, if the electron withdrawing group, or suppose let us see if minus I and minus R effect increases, minus I effect and minus R effect decreases the basicity, considerably explain. So what do you mean by the minus I effect and the minus R effect? Suppose as a aromatic compound, let us see first one. As we know that the amines are there, aromatic amines. Now aromatic bases we are talking about. Let us see first one we have seen here, and show me, tell me what is the name of this compound. Everybody knows that this is the name of the structure is a aniline, right? And aniline we know that pKb value is a 9.4 roughly, not exactly, roughly it is. And now suppose this hydrogen atom get replaced by another phenyl group. I am trying to write here N, then H, another structure of benzene. What I am doing here, I am go on adding or go on replacing the nitrogen atom by electron withdrawing group like as a benzene. So this is a aniline, this one is a diphenyl aniline, we can call it diphenyl aniline. What is happening here? The pK value is, I think, goes on decreasing. So pKb value nearly found to be, I think, 13 point something 5 roughly, you can remember. As the pK value increases, the basicity goes on decreasing. pK value is a less, this one is a greater, so this one is a less basic as compared to the this one, because there is a steric effect involving here. Now look at another one. Let us see another structure N. Then I am again connecting or attaching the one more, that is a triphenyl aniline, which is nearly neutral in nature. pKb value is found to be, I think, 14 something, and that is a neutral in nature. So in this way we can remember this is the second application of the minus I inductive effect decreases the basicity of this compound. Here only one aniline group is there, and here two phenyl group, both are electron withdrawing groups are there, and withdrawing group exerts the minus I effect in these cases, and therefore the basicity goes on decreasing considerably due to the steric effect as well as minus I inductive effect. This is about the second one. Now let us look at, suppose if we have third application here. Third application, nitroanilines are weaker bases as compared to the aniline. Nitroanilines are weaker bases than aniline. Explain. How do you explain this? Yes. First, what is our nitroaniline? Everybody knows that the nitroaniline. Structure of aniline, just now we know that structure of aniline. First let us draw the structure of aniline here. This is the structure of aniline, NH2, right? And this is the structure of aniline. And now nitroanilines are present in 3 isomeric form. Isomers means what? Same molecular formula but different structures are known as a isomer, and that phenomenon is known as a isomerism. Now let us look at as a first structure of the first one. Now just you tell me the name of this aniline, this one, NO2, that is a NO2. What is this? This is a orthonitroaniline. This one is a orthonitroaniline. As we know that pK values, that is pKb values are 9.4 here, and this one pKb values are 9.62 or something. Or 80, and another one roughly I am giving as a values of that. This is a NH2, one group is attached here. This one having as a pKb value is near about 9 point, I think 8 or something. Then maybe this one NH2 and NO2. This one is called as a meta-nitroaniline, right? And what is the name of the last structure? The name of the last structure is a para-nitroaniline, and this having as a pKb value is roughly, I think this one is a somewhat 9.5 something you can write, remember, and this one may be as a 9.60. okay, that are the sum of the pKb values. And what do you see here? These nitroanilines are weaker bases as compared to as a aniline. Their pK values is increased due to here at ortho position it exerts -I inductive effect as well as -R inductive effect. This -I inductive effect and the -R inductive effect are shown by this due to the nitro group. Nitro group is a electron withdrawing group, and therefore it strongly withdraw the electron density from the benzene ring, and that's why it exerts both kind of the effect here, -I as well as -R inductive effect. But there if you draw the resonating structure, there you will find that nitro group is not involving in the resonating form, and therefore it is slightly what we can call it as a weaker base than this 2-1. And now here this one is a weaker base because nitro group again showing as a -I as well as -R inductive effect. And remember as a one thing here, if the -I and -R inductive effect goes on increasing, basicity also goes on increasing. That is the point you should remember while discussing such type of the questions are. Now let us move on to the next one, fourth application. The fourth application will be if the nitro groups, if the nitrogen atom gets substituted by alkyl group, then the basicity is not changing considerably. That is the fourth application. If alkyl group is substituted, or you can call it as a N substituted, then the basicity is not basicity not change considerably. What is the reason? Considerably, what would be the reason, or how do you explain this one? Now suppose let us look at here some of the suppose we know that let us consider as the general aromatic amines we are talking about. So first one is a aniline. Now 100% T.Y.B.Sc student, you are knowing the structure of aniline, right? Now this is a structure of aniline. What I am doing here, now I am substituting this nitrogen atom by one methyl group, another one again is a here N CH3 and CH3. This what I did, I replace all the nitrogen atom by the alkyl group. Here this is a structure of aniline, and as we know that aniline pKb value of aniline is a 9.4, and that when this is a methyl group attached to that nitrogen atom, and therefore it is somewhat pKb value somewhat increased, and the name of this compound is N-methyl aniline. And what will be the name of the last structure? That is called as a N dimethyl aniline. This is a structure of N-dimethyl aniline, and pKb value is I think 9 point, they are slightly 9.5 or 10 point, you can pKb value maybe as a 10.0, like that you have to remember, as they, but not much, they are increasing slightly. Now let us move on to the next application, that is the application number 5th one. If the aromatic compound gets substituted by fifth one, application number 5th one, if electron donating group attached to the benzene ring, then the basicity goes on increasing. If plus I and plus R effect increases the basicity of aromatic bases, right? Aromatic bases. Now this is a fifth application. If plus I and the plus R effect increases the basicity of aromatic bases. Now let us look at here. Suppose we have this structure, the NH2, as we know that aniline has a pKb value is not minus 9.4 as usual. And now suppose let us see here, I am connecting suppose as a NH2, and then I am putting methoxy group at para position. There are again 3 structures are there, methoxy group at meta position, then ortho position, and then now at para position. What is going to happen? They are donating electron like this, so that the what we can call it as, due to this plus R inductive effect as well as plus I inductive effect, they increases the basicity of this. So pKb value is found to be 8.5 something is there, and so that they are the increased one. Suppose you have ortho, let us see here, this NH2, this is known as a OCS3, or here you can draw this maybe as a NH2, and at meta position this is called as a ortho methoxy aniline. This one we can call it as ortho methoxy aniline. And what will be the structure of this? This is the meta methoxy aniline. This is a structure, and this is a para methoxy aniline. Para methoxy aniline. These are the structure, and they are slightly stronger bases than the normal alanine. This is all about the aromatic bases. I think remaining application we will see in the next lecture. Let us stop today here. Have a nice day. Thank you.